Okay, so on this, we are going to be using only the tangent ratio. And the first thing that you got to make sure that you have, this is only dealing with a right triangle. And I'm only going to give you right triangles, so you really don't have to worry about that. Now let's first start with focusing on the parts of a triangle, okay? So we're going to look up here at our triangle, and on our triangle, we've got the sides. So you've got your right angle right here, and you've got your legs. So you've got your legs here, A and B. And your hypotenuse is C. Now, we know that our hypotenuse is always the longest side, and it's always opposite from the right angle. Okay, so C is always going to be known as the hypotenuse, and like we said, it's always opposite from the right angle. Okay, so C is our hypotenuse, A and B are legs. Now, we've got some Greek letters here. This is alpha. We call this alpha. It looks like a fancy little A, or when you see me write it, when I actually draw it, it's going to look like what we call it, a lot of you call it like the Jesus fish. So that's alpha. So alpha is always opposite from A. So even if I were to draw a triangle, and if I put side A down here, it doesn't matter where side A is, but if side A is here, alpha would be moved up here, okay? So A and alpha are always opposite from each other. They're never going to be close together. And the fancy B that you see there, that is beta. So it's basically just B. So when I draw it, it's just B, and it's just kind of got like a little tail to it. So B, or beta, is going to be opposite of B. And then over here are two facts over here. Alpha and beta are always going to add up to be 90 degrees, which makes sense because you already have a 90-degree angle, and 90 plus 90 equals 180 degrees. And we have 180 degrees in a triangle. So naturally, if you've already got 90 degrees, you need another 90 degrees to equal 180. And then this right here, a squared plus b squared equals c squared, that is your Pythagorean theorem that you've already learned about in the past. So that's just Pythagorean theorem. Okay, now let's talk about tangent ratios. I love trig, and I love our sine, cosine, and tangent ratios, and you're going to learn about sine and cosine tomorrow. So tangent is opposite over adjacent, and what tangent allows us to do is it allows us to use an angle and the ratio of two sides, and as long as we know 2 out of the 3. So this right here is an angle, and this symbol here is actually called theta. It's pronounced, that's how you would say that, theta, okay? So that represents an angle. So as long as you know one angle and one side, or even if you don't know the angle, if you know two sides, you can figure out the angle. So if you know an angle in one side, you can figure out the other side. Or if you know two sides, we can figure out the angle. And that's what we're going to do. So first, in example 1, we are going to just practice finding the tangent ratio and practice figuring out what opposite and adjacent mean, what opposite sides and adjacent sides in relation to the tangent angle. Okay, so example 1, find the tangent ratio of each triangle in relation to alpha and beta. So if we find what's tangent to alpha, so theta is just a general term for the angle. So if we're going to find tangent to alpha, and most of the time what we'll do here, theta just represents the angle up here, okay? So what we do here, we already know 5 is the hypotenuse, okay? So you look and see, well, what is adjacent? Now remember, adjacent, we'll write it up here. Adjacent just means beside. That's what adjacent means. Adjacent means beside of, okay? So adjacent, I mean, literally, what number is adjacent to alpha? Is 3 beside of it, or is 4 beside of it? Well, 3 is beside of it, okay? And 4 is going to be opposite because it's across the triangle, okay? So it's opposite over adjacent, so it's going to be 4 over 3, okay? Now, if we switch things up here, and if we do the tangent of beta, okay, so now we're looking in relation to beta. We're going by the beta angle. We're doing opposite of beta. So opposite from beta is 3, and 4 is adjacent because 4 is beside of it. So it would be 3 over 4. It's just basically flipped. Okay, so tangent of alpha is 4 over 3. Tangent of beta is 3 over 4 because it's all in relation to the angle. Okay, so now if we switch and we go to B, if we do tangent of alpha, opposite of alpha, because we know this is the hypotenuse, the first thing to do to help you is go ahead and label your hypotenuse, because we're not using hypotenuse at all in tangent. Hypotenuse is never used. So label it so you know you're not going to use that number, because that way you know it's not adjacent, it's not opposite. That can't be used at all because hypotenuse is its own thing. So 6 is opposite, and then 8 is right beside of it. Okay. All right, so now if we go to using beta, so if we're using beta, you go opposite, go across the triangle. So 8 is opposite, which means 6 is adjacent. Okay, so now if we do tangent of alpha on this one, so alpha you go, so let's label hypotenuse first. 15 is our hypotenuse because that's our longest side. So opposite is going to be 9, which means 12 is adjacent. Okay. Then if we go to tangent of beta, so if you go opposite, the one that's furthest away, you can think of it like that too. 12 is opposite. 9 is adjacent. All right, and then our last one here, tangent of alpha. So here's our hypotenuse. So if we go to alpha, you go opposite. 7 is opposite. 4 is adjacent because 4 is right beside of it. Oops. And then if we do tangent of beta, so go opposite, there's opposite, 4 is opposite, and 7 is adjacent. Okay, so now what we're going to do, this will actually tell us what those actual angles are, okay? So if you know the opposite and adjacent sides of an unknown angle, you can use inverse tangent. So this right here, even though it says tangent to the negative first, you actually say inverse tangent. That's called inverse tangent is what that's called. You use inverse tangent to find the angle measure. So be sure your calculator is in degree mode. So to get in degree mode, what you do is you hit the mode button on your calculator. You go to the third row down and make sure it says degree. Make sure degree is highlighted. And then you hit second quit to get out of that. So whether you have this app, this pink app here on your phone or on your iPad, or if you have it downloaded on your computer, the TI app on your computer, you've got to have this on your computer. So you've got to have one of those because you absolutely have to have it so it works on your computer. So for here, if you hit the mode button, okay, and like I said, it's the third row down. So if you look the third row down, I've already got degree highlighted right here, okay? And then if you hit second, quit, it just takes you out to the main screen. And then if you notice, kind of in the middle of our screen here, it already says tangent, or it says tan is what it says. It's abbreviated. So if you look about 2 keys up above the 9, that's where you'll see tan. And then what you have to do to get inverse tangent is you have to hit second tan So if I hit second tan, and you'll see that that inverse tangent will come up on the screen here, okay? And so for our first problem, to calculate the angle, it tells you to hit the second button, and then it tells you to hit tan, which is going to give us that inverse tangent, and then we'll enter the ratio. So what we're actually doing here is we're going to find the measure of each angle from example 1. So if we're going to find alpha for number 1, I've already got my inverse tangent. I'm going to type in 4/3. So if I go back here, I'm going to type in 4/3 and hit enter. So that measure is 53.13 degrees. So if I go back here, it would be 53.13 degrees. And then if I do beta, okay, I would do the inverse tangent of 3/4. Okay, so I would hit second tangent 3/4. I'm just doing the opposite. And I would get 38.87 degrees. I would round. So it would be, let's see, I've already forgot here. 36.87. Okay. 36.87 degrees. And those are my two angles. All right, so for B, I would do second tangent of 6/8. And I would get 36.87. Okay, so alpha is 36.87 degrees. And for beta, I do second tangent 8/6. So I get 53.13. All right, so for C, I would do second tangent of 9/12, 36.87. A lot of these are the same fractions, they would reduce to the same fraction, so it kind of makes sense I'm getting the same thing over and over. So let's see here. So alpha is 36.87 degrees. So it only makes sense that beta is 53.13 degrees. I'm just going to skip that one because I know it's going to be the same. Now D is going to be different. So alpha, let's see here. Alpha is going to be 7/4. So I'm going to get 60.26 degrees. And then beta, so I do second tangent of 4/7, 29.74. Okay, so that's how you get the angles. Now, if we're going to find the missing side length, so this is slightly different. If we're going to find the missing side length, we're going to set it up just a little bit different. Okay, and we're still using tangent. So we have the tangent of 43 equals, okay. Now, we got to figure out which one's opposite and which one's adjacent. So if you go like across the triangle, X is opposite, 5 is adjacent, okay. So we're solving for X. So when you're solving for X, 5 is on the bottom of your fraction. So when 5 is on the bottom, you need to move it up and over to the other side. So 5 is going to go up and over to the other side. You're going to multiply by 5, okay? So you have 5 times the tangent of 43. You just move 5 to the other side. So you're solving for X. You're just solving an equation for X is all you're doing, okay? So we're going to do 5 times the tangent of 43. Now, this is a regular tangent. The only time you use the inverse tangent is when you're looking for an angle. So this is regular tangent. So notice what I'm going to type in here. I'm doing 5 tangent 43. Okay, so notice I just typed in the tangent. And so that's going to be 4.66. Okay, so 4.66 equals x, okay? Because I'm looking for a sides. And the way that I always tell students how to remember this is sides don't get seconds. Sides don't get seconds because I'm not hitting that second key. I was hitting the second key when I was looking for the angle. Don't hit the second key when you're looking for a side. I'm looking for a side, so don't hit the second key, okay? All right, so on the next one here, I put the tangent of 52 because I know what the angle is. There's no symbol here. Tangent of 52 equals, go opposite, 8 over x. Now this time I've got the x on the bottom. So these two switch places, okay? So here are the two types of problems that we're doing. Either x is on the bottom or x is on the top, okay? When x is on the bottom, they switch places. So when they switch places, it's going to be x equals 8 over tangent of 52. And so x is going to equal, and I'm going to go to my calculator and I'm going to type in 8 divided by tangent of 52. So 8 divided by tangent of 52. And I get 6.25. Okay. So on my next one, I have the tangent of 61 equals, I figure out what my opposite is. My opposite is x over 12. So x is not on the bottom, x is on top, so I multiply by 12. So I do 12 times the tangent of 61. 12 times the tangent of 61. And I get 21.65 if I round to one decimal place. 21.65 equals x. Okay, on my next one, I have the tangent of 32 because the degree, the angle always goes next to it. Either it's one of those Greek letters, alpha or beta, or it's the actual angle that we know. My opposite is 7 over x. Since x is on the bottom, these two switch places. So x goes over here, and I have 7 over tangent of 32. So I'm going to type in 7 divided by tangent of 32. And I get 11.20. So x equals 11.20. So if you feel comfortable enough, pause the video and try these 4 on your own. Or if not, maybe watch one more and then pause and see if you can do a few on your own. Okay, so for this one, tangent of 43, your opposite is x over 20. Since 20 is on the bottom, it goes up and over, and you do 20 times tangent of 43. So 20 times tangent of 43, and we get 18.65. So 18.65 equals x. Okay, on this one, we do tangent of 56. The opposite is 4 over x. Since x is on the bottom, they switch places. So x equals 4 over tangent of 56. So I do 4 divided by tangent of 56. And I get 2.70. That's going to round to 2.70. So x equals 2.70. Okay, on this one, tangent of 65. My opposite is x over 18. So 18 is going to go up and over. Oops, I was trying to switch, but I didn't need to. So I multiply by 18. 18 times tangent is 65. 18 times tangent is 65. 38.60. So 38.60 is my x. Okay. And on the last one here, tangent of 38, my opposite is 8 over x. Since x is on the bottom, they switch places. So x equals 8 over tangent of 38. So 8 divided by tangent of 38, and I get 10.24. So x equals 10.24. Okay, so we get a couple of word problems here. We have to draw our own triangle. The side of a building, so anytime it talks about the side of a building, assume that it is formed, it's just a straight line to the ground, forms a right triangle with the pavement. So here's our right triangle. It casts a shadow 200 feet. So think about where a shadow is. The shadow is going to be on the ground. So there's our shadow on the ground that's 200 feet. What's the height of the building? So here's our height of the building. I'm just going to call it X. I don't want to call it H because that can be confused. That could confuse us and we may think like hypotenuse. So I never call anything H or whatever. I always just like to call my stuff X. Okay. So it forms a right angle with the pavement. And let's see, I think I left out, some information. I should have told you here that the angle of elevation is 20 degrees. I should have told you that information. Okay, so the angle of elevation is 20 degrees. All right, so you should know that. That should have been given to you. Okay, so with this, we know we're using tangent. So tangent of 20 degrees, our opposite is x over 200. So we're going to move 200 over here. We're going to do 200 times tangent of 20. So 200 times tangent of 20 equals 72.79, and it tells us, it doesn't tell us to round to anything, so we'll just round to 2 decimal places like we've been doing. So 72.79. So 72.79. Okay. Oh, it does say round to the nearest foot. Sorry, I didn't see that. So what is to the nearest foot? So we would round, we would say 73 feet. Okay. A skateboard ramp is built at an angle of 12 degrees. Okay, so we know we're dealing with a right triangle. Okay. Skateboard ramp is built at an angle of 12 degrees. The distance from the bottom of the ramp to the incline is 5 feet. So the bottom of the ramp to the incline is 5 feet. Okay. How high is the ramp off the ground? So it's wanting to know the height right here. Okay. So once again, we're dealing with tangent. The tangent of 12. Remember, your angle always goes right by your trig function. Okay. So keep that in mind as you're doing these problems. All right. Go across the triangle. That's always your opposite. And then 5 is your adjacent. We move 5 over here. So 5 times tangent of 12. 5 times tangent of 12. And it's going to be 1.06. So it's about 1 foot off the ground. About 1 foot. And that concludes our notes.